Okay, this is Advanced Math Trig again. This is Mod 7. Guys, it's Tuesday, March 31st. This is our second lesson of the new grading period. If you could get a sheet of paper out, have it out on your desk or on your table, wherever you're doing this, phones away, other things away, distractions away. This will not take long. It's a topic called linear trig equations. You should also have out on your desk or your table the unit circle that you pieced together yesterday. Have that out ready to look at and be referenced to. I've got mine with me over here so I can use it as well. And all you're going to do today is, if you could, you might as well divide your paper into 4 sections like I've got here. And we're going to do one problem in each block. And if we can work our way through all 4 of these problems, that's our entire goal for the day. Again, it's a nice, hopefully well thought out, well explained lesson that you can then try a few practice problems and submit to me via email by tomorrow at noon. Remember, as I said, those problems will be graded not only for completion, but also for correctness. So it's critical that you focus, pay attention to my explanation. You can always pause this or rewind this or watch this video again if you have to, if you're not clear on how to do it. So you might as well save time and really focus and pay attention with me the first time as you're taking your notes, okay? All right, here we go. As you look at all 4 of the problems on this paper, obviously an equal sign is involved in each problem, making it an equation. This one has the word sine, the second one has cosine, the third one has cosecant, the fourth one has tangent. Also, there are trigonometric words involved, so there are certainly trig equations. And notice this is just sine to the first, cosine to the first, cosecant to the first, tangent to the first. There's no sine squareds or cosine squareds or square roots of tangents or cosecants. It's just a nice linear trig equation. And in theory, as you'll see, each one of these is supposed to have 2 answers. Now, our goal on each question, of course, like any equation, is to solve for the letter x. How big is angle x in this first equation? How big is angle x in this second equation? How big is angle x in the third equation? And how big is the missing angle x here in the fourth equation? The goal on all 4 of these is to, first of all, get the trig word to end up all by itself. So if you look at problem number 1 here, my goal is to get the word sine of x to end up all by itself. It's almost like that's a big radical box. Remember when you were solving radical equations, you tried to get the radical box to be by itself? Let's get the word sine to end up by itself here. So obviously I'm going to plus over the 1. The 1's would cancel. I've got 2 sine x equals 1. And my last step, of course, is just to divide by 2. The 2's cancel, and I did it. The sine of x equals 1/2. Now, kind of like I said yesterday when referring to this when we did our unit circle, that does not mean the answer to this equation is x equals 1/2. This says the sine of x equals 1/2. I've got to find the missing angle x here. In other words, angle x, my missing angle, is equal to what? Well, to answer that question, all we've got to do is refer to our unit circle. Basically, this is saying, when does sine equal 1/2? And remember, the rule on the unit circle is all the ordered pairs that are on there, the x coordinates are your cosine value and the y coordinates are your sine value. So this question is really asking me, when you look at your unit circle, when is the y coordinate going to equal 1/2? So get your unit circle out. I've got mine right here. I'm going to look all the way around my unit circle and find out when is the y coordinate equal to 1/2. Well, you notice right away it happens here at pi over 6. And as I go around, again, I'm looking for a y coordinate of a half. Right there it happens at 5 pi over 6. Now notice this is negative a half, and as I go around, that's also we want positive 1/2. So the answers to this question are pi over 6, and again at 5 pi over 6. I did it. I found the two missing answers. So back to my question. I'm going to write angle x equals pi over 6, and the second answer is 5 pi over 6. I did it. I solved my linear trig equation. So with that thought in mind, let's try to zip through these other three. All right, question number 2. Obviously, if my goal is to get the word cosine to be by itself, my first step is to subtract over the 5. The 5's cancel. I have 6 cosine x equals negative 3. Divide by 6, and I did it. Cosine of x would equal what? Negative 1/2 when you reduce 3/6. So now I'm figuring out, or going to try to figure out, as I look at my unit circle, when does cosine equal negative a half? Now remember, cosine are all the x coordinates on my unit circle. So if I go to my unit circle, and I'm going to follow around until I see an x coordinate of negative a half, there it is at 2 pi over 3. So there's one of my answers. Where else does cosine equal negative a half? When is the x coordinate negative a half? Right here at 4 pi over 3. So I successfully found the two answers to that trig equation. 2 pi over 3 and 4 pi over 3. So angle x equals 2 pi over 3, comma, and the other answer, 4 pi over 3. All right, third one. Now a little bit different because it's got the word cosecant involved. Don't let that fool us. Our first job is still to get that word by itself. So we're going to add over our 2. The 2's cancel. I've got radical 3 cosecant x equals 2. Divide by radical 3. Divide by radical 3. The radical 3's cancel. And cosecant x equals 2 over radical 3. Now obviously, if I look at that question, the problem is it's got the word cosecant, doesn't it? Oh, well, let's think about this. How would we handle this? Everyone listening to me right now should agree that the word cosecant is the reciprocal of sine, isn't it? So I'm going to change the word cosecant to the word sine of x, and I'm allowed to change the word cosecant into the word sine as long as I take the answer and reciprocate it, right? Because they're reciprocals. So if I flip that over, I get radical 3 over 2. So the question becomes, when does sine equal radical 3 over 2? Again, remember, sine is my y coordinate. So I'm going to look at my unit circle, and I'm looking for a y coordinate of radical 3 over 2. It happens right there at pi over 3, and again right here at 2 pi over 3. So my answers are angle x equals pi over 3, and the other answer was 2 pi over 3. So because those are the two times on the unit circle where my sine value, my y coordinate, equals radical 3 over 2. Not bad. Haven't missed one yet. And finally, question 4 just says tan x plus radical 3 equals 0. Of course, if we're trying to get the trig word to be by itself, I'm going to subtract over the radical 3. He's gone. I've got tan x equals negative radical 3, and I'm done. So the question becomes, when does tan equal negative radical 3? Now, we got a problem here, don't we? Once again, we've been saying this whole section, cosine is your x coordinate, sine is your y coordinate. Well, remember from those trig identities we did way before we left school, the last thing we were doing, Does everyone agree that when you see the word tan, it's really sine over cosine, isn't it? The formula for tan is sine over cosine, which of course would be y coordinate over x coordinate. So I want to take my y coordinate, put it over top of my x coordinate, and get an answer of radical 3. I'm ignoring the negative sign for a second. So when can you take a y and put it over top of an x and get an answer of radical 3? Well, think about it. If I look at my unit circle real quick and I focused on this ordered pair right here at pi over 3, do you agree the y coordinate is radical 3 over 2? The x coordinate is 1 over 2. So if I take radical 3 over 2 and put it over top of 1 over 2, the 2's would cancel because they're the same, leaving me with radical 3. Now, obviously, our answer was negative radical 3, not radical 3. So doesn't that mean that I need my y and x coordinates to have opposite signs? So I know the answer to this question is going to be angle x equals, and I'm going to have 3 on the bottom, the pi over 3 value, but I want my x and y to have opposite signs. So as I go around my circle, when do I have a 3 on the bottom, a multiple of pi over 3, and yet the signs are different? It happens right here in quadrant 2, and it also happens over here in quadrant 4. So my answers are going to be 2 pi over 3 and 5 pi over 3, because at both of those spots, when I put y over x, I get an answer of negative radical 3. So the answer to that last question, as we just said, would be angle x equals 2 pi over 3 and 5 pi over 3, and I did it. So a very basic introduction to linear trig equations. We'll do some more of these tomorrow. Notice we're not going to try to get too much done each day. This video probably took about 12, 13 minutes to get all that done. And now your job is simple. To prove you understand all that, you're going to do an assignment. It's due the next day by noon. So Wednesday, April 1st at noon, this homework assignment will be due. And all you've got to do is hit pause for a second and copy down these 4 problems as your homework assignment. Yes, you'll get a point or 2 for attempting it, a point or 2 for the right process, and then a point or 2 for the correct answers. We've got a grade based on correctness because this is how your grade is going to develop and build up and how you're going to be evaluated till we get back to school, if we get back to school, and can start taking tests and quizzes and things like that. I'm just going to give you a daily grade based on your understanding of what I just taught you. So copy these 4 problems down. This is your homework assignment for tonight, for today. And it's due Wednesday, April 1st by noon. All you do is scan it and send it to my email, scott.galeta@lipapps.org. Or, of course, you can just take a picture on your cell phone and send it to my email when you're done with that, okay? Thanks, and we'll see you tomorrow on Wednesday. Good job, guys.